Please.
Yes, ma'am. So we're going to discuss the investigation first. Some of us did wonderful job. Some of us have issue understanding the main requirements. And some of you just have issue with computation. So somebody said we could look into the correction. I got a private message over the weekend and actually specifying, indicating question 4. And somebody also mentioned this morning, oh, maybe we could look at the correction. So I thought maybe we'd do that. Because what I actually plan to do, the first class, is to solve questions based on those stuff. Those are findings. I'm sure you saw my feedback. Yeah, so we're just going to do that together now. So the questions goes thus. So correction from investigation. Is everybody in class? Yes? Yes. Okay, good. So the first question, 1, says, expand each of these and collect the like term. Since you have done it, so I just need you to tell me if I'm being rubbish or not. F2x. I already said at the beginning that fnx means a polynomial of degree n. So f2n means a polynomial of degree 2. And I have a x minus alpha, x minus beta. Someone told me, oh, I couldn't do the symbol, so I changed it to A, B, C, X, Y, Z. That's not allowed next time, please. We must learn to write those letters, okay? So, this is simple expansion, it's easy. X squared minus beta x minus alpha x plus alpha beta. And could be x squared minus beta plus alpha x plus alpha beta. And like I wrote in some of you, you don't have to expand with a. You can leave a out of this, right? So you have a bracket x squared. I'm just rearranging in alphabetical order, okay? Just like when you multiply a times b, you say ab, right? You don't, even if you do b times a, you still write ab. So I'm just rearranging it. That's English letter, this is just Greek letter. Okay. So we don't want to be biased. For English, we write alphabetical. For Greek, you decide to write otherwise. That's being biased, right? We don't want to do that. Anyway, F3, not from 3. So, F3x is a x minus alpha, x minus beta, x minus gamma. I write my gamma just like this, just like y, just bend it a little bit. Some people will write maybe this way. So that, because this is the first two, so it's basically f2 times that. So we just bring in this, so that's a into brackets x squared minus alpha plus beta x plus alpha beta, then multiplying x minus gamma. Okay, so I'm still going to leave a out of the whole thing and just multiply these two. So x squared times this will be x cubed. Then I have x squared times the second one will be gamma x squared. Am I right? If this is confusing, I can go back to the one that looks like y, because the symbol needs to actually look alike. Otherwise, collecting the like terms might be a problem for some of us. So x squared times that will be, now all these gamma are numbers, they are constant, so they should come first before the variable. Okay? So if you multiply this by this, you get a square. So I'm going to put that under, and that's a negative alpha plus beta x squared. Yeah? And this by this will be positive alpha plus beta. What? Yeah? Am I right? Yes. Then there's a gamma, then x. Please confirm. I multiply by this, I get this. I multiply this by this, then I get that. So alpha beta now. So I have alpha beta x. So it's going to be here, alpha beta x. Then plus, no, minus now, alpha beta gamma. Yes? So I still leave a outside the bracket, x cubed So if this and this are combined, you notice both of them have minus, alright? And both of them have x squared. So I can have minus outside, so I have alpha plus beta plus gamma. Yes? Talk to me, please. Alright, so alpha plus beta plus gamma, then I have x squared, then plus. So this is alpha beta. If I open this bracket, is alpha gamma and beta gamma. Both of them x. So it will be alpha gamma, beta gamma, x. Then this is alpha, beta, and gamma. So if you look at it, from the first one, you have addition, it's like individually first, then product. So you have combination, this is combination actually. You can now use your knowledge of combination and combination a little bit to know if you have collected all the like terms. If you are dealing with 2, remember when we talked about subsets? You start with empty, then you start with singleton, then you start with set of 2, then you start with set of 3, up to everything. Do you remember that? Hello? Do you remember that? So it's similar here. That's how you know if you are missing something or not. That is how I know, when I look at your last step, I know if someone has made a mistake or not, if I do not see that pattern. What pattern am I looking at? There are 2 roots or 0, depending on whether it is an expression or equation. After the first term, I should have combination of individual addition of roots or zeros. The next term will consist of the combination of 2 in every possible way. The combination of 2 is actually everything because they are just 2. That's why it ended here. But in this case, we have 1 in 3 possible ways. Now if you want to combine 2, you can have this and this, this and this, or this and this, and they are all here. The next is the combination of everything, and everything is this. So we stop here. That's how you know if you have done something right or wrong. And for the last one, which is F4x, it is simply a x minus alpha, x minus beta, x minus gamma, and x minus delta. That's like ABCD. This 3 is everything here. So A, we have x cubed minus alpha plus beta plus gamma x squared. And also, again, the series is alternating. The first one is positive, second is negative, third one is positive. Positive, negative, positive, negative. That's another thing I was looking out for in your work. So if you see me doing like a kind of circle, this is the reason, that's how I know. So how you made the mistake, we may not know, but you have made a mistake. That should be something to notice. Yeah? So here, this will be plus, this one. Alpha, beta, gamma, beta, gamma, x, right? Q square x. Then the constant will be everything, which will be negative because this is positive now. Okay? That will be alpha, beta, gamma. Wait. Yeah. Then we have x minus delta. I'm sure you are used to this delta maybe in your biology or physics, which is change, right? This is capital letter. This is small letter, just like D and D in English. Okay? Both of them means change. Okay. We're going to be talking about this in maybe derivative. We call it partial derivative. Anyway. Okay? So, we expand again. I still leave A outside because we don't care about it. We don't need it. Nobody cares. Maybe nobody likes him. I don't know. That will be x to the power 4. Then minus x cubed delta. Agree? So I'm going to put some spaces there. X cubed delta, or delta x cubed. Delta is a constant. Delta x cubed. Yeah? Then we multiply the second term by this. And that will be x cubed with this as the coefficient. So we have minus alpha plus beta plus gamma x squared. No, x cubed. Please talk to me. Alright? Then we multiply this also by this. That will be positive. So we have positive delta alpha plus beta plus gamma x squared. Yes? Then the next one is this. With this, that's also positive. X squared. So plus alpha beta alpha gamma beta gamma x squared. Then this multiplies this will be minus delta, then the brackets alpha beta alpha gamma beta gamma x. Am I right? The last one is this times this. We get x again under this. It's a negative alpha beta gamma x. Then finally alpha beta gamma delta. Okay? So let's write that here. This implies f4x equals, the first one is okay, x to the power 4. Then the second, if you come here, look at this. Both have x cubed, so x cubed will be outside the bracket. Both have negative, so negative will be in front of the bracket. In the bracket, we're going to have this also included. So it's going to be alpha plus beta plus gamma plus delta, if you arrange it in order. Now for this, both will be positive. Yeah? Both will be squared. So while we have combination of 2, here, this will also be combination of 2. So alpha times this, beta times this, alpha times this, beta times that. Okay, we can arrange in alphabetical order. Okay, we can take care of all the alpha first, then we'll take care of all the beta first, then all the gamma first, then the delta follows, just to be in order. You don't have to be in order, it's just easy to know if you are missing something or not. Then, for this, we have a combination of 3. You can see single, pairs, triple, and 4. Can you see the order now? Yeah? And for this, now if you